All right, so in this video, I'm going to go over the FRQ part B, which is the non-calculator portions of the FRQs. And so this first one, it has a graph of G, which is here, and it tells you that it's a continuous function. It also tells you that it's twice differentiable except at x equals 0. And our bounds are from -3 to 3. And so we're given another function as well. So f, we have a second function, and it says that f of 0 is -1, and then f prime of x, so the derivative is going to be x squared minus 5 over 4 times e to the x. So make sure you look at all the different pieces of information they give you. Each piece is going to be important or useful in some way. And so let's see what it asks first. It says find the x coordinate of each critical point of f, and then classify each critical point as the location of a relative minimum, relative maximum, or neither. So in other words, we're just trying to find where f has a relative min and max. So first thing we want to do is, well, in order to find the critical points, we have to use our derivative. So I'm going to do that down here. So you should have the question with you, or just pause the video and read the question. But for now, for A, so we have our derivative of f, and we want to find out when it's 0 first to find our critical points. So in other words, when is this equal to 0 or undefined? And this function isn't going to be undefined anywhere because you could plug in any value of x and it would be true. But there's only certain values you could plug in for x in order for it to get 0. So we have two things being multiplied. So either this x squared minus 4 or 5 over 4 equals 0, or this e to the x equals 0. Well, e to the x is never going to be 0 no matter what x value you plug in. So we're mainly just looking over here. So in other words, when x squared is equal to 5 over 4, do some solving there. And so what you end up getting is x is equal to positive and negative square root 5. And I'm going to simplify that to over 2 instead of square root of 4. So these are going to be our critical points. Again, if you want to make note, not undefined anywhere. So I'm going to create a sign chart. So for the values of negative square root 5 over 2, and also positive square root 5 over 2. And so here you're going to use this for your derivative, right? Don't make sure you don't plug it into your original function because the sign of the original function isn't going to help you with the critical points. So if I plug in something super negative, so like maybe negative 100 into my original function, well, here x squared, that's going to be turned into positive minus 5 over 4. So it's still going to be positive for that first section. And if you plug in negative for e to the x, like negative 1,000, well, it's still going to be positive, but just a small number. So it's positive and positive. So what we end up getting is positive here. If you plug in something between negative square root 5 over 2 and positive square root 5 over 2, something like 0, for example, well, in the first group here, if you plug in 0 for x squared, well, that'll give you 0 minus 5 over 4, which is negative. And then e to the 0, that would be positive. So what you end up getting is a negative here. And then again here, plug in something super positive, like a really large positive value, like 1,000 or 1,000,000, you get a positive and then a positive here. So in the end, in this interval, our derivative is positive. So it turns positive, negative, positive, and then that's going to tell us whether we have a relative maximum or minimum. So here, hold on, let me just read the question again. Okay, so we're trying to find relative maximums. Okay, so at this value here, our derivative is positive, so that means our function is increasing, and then it's negative here, so then our regular function is decreasing. So that tells us at x equals negative square root 5 over 2, Let me just make sure I'm putting this in the right way. Yeah, at x equals negative square root 5 over 2, f has a relative maximum. And then make sure you put this with your like justification or your explanation. Because f of x changes sign from positive to negative. And then at that specific point, so you could say at x equals negative square root 2 over 2, or you can just say right there. And then on the flip side, so at x equals square root 5 over 2, f has a relative minimum because f prime of x changes sign from negative to positive. And that's good enough explanation there. Unfortunately, the sign chart isn't going to be justification because it's not very, I guess, mathematical or formal. So you do have to write out because f prime of x changes sign from negative to positive or positive to negative. All right, so that's part A there. Now moving on to part B. So part B, I'm going to take a look real quick. It says, find all the values of x at which the graph of f has an inflection point. Give your reasons and your answers. Give reasons for your answers. So inflection points, if you don't know, that has to do with our second derivative of our function. So we're going to have to derive f prime of x. So f prime of x, again, was x squared minus 5 over 4 times e to the x. So in order to get our second derivative, I am going to have to use product rule here. So I like to do derivative of the first. So that's going to be my first group here, and then times my second, which is e to the x, plus my first times the derivative of e to the x, which is just e to the x. So I'm going to simplify this a little bit. I get this here. And so for inflection points, you need your second derivative to be equal to 0, and it changes sign. So this one, if you want to figure out where it's equal to 0, you could either use the quadratic formula, or a little trick that I would do is multiply the inside of this group by 4, but to keep this equation the same, you're going to multiply by a fourth on the outside. So my next here is going to be 1/4 e to the x, and now we have our new equation, 4x squared plus 8x minus 5, and then you could factor this. So you'll get negative 20 on top, 8. So it'll be 10 and negative 2 are our factors. And so what you end up getting for your factors are 2x plus 5 and then 2x minus 1. And you still have the 1/4 e to the x there. Again, you don't have to do it this way, but it's a little trick that you could do. And so the x values you end up getting, regardless of what method you do, is negative 5 over 2 and then positive 1/2. And so if we want to make sure that these are actually inflection points, we're going to have to make a sign chart. And so because it's inflection points, we're plugging it into our second derivative. And so here, if you're plugging in something in this interval, you can plug in like negative 1,000, and then make sure you plug it into your second derivative here. So if you didn't do the trick, you'd probably plug it into this over here. So you'd get negative 1,000 squared which is going to be a big number, and then minus 2,000, which isn't going to be enough. So it'll be positive and positive, because each of the x to 1,000, negative 1,000 is still positive. So here we get a positive. From negative 5 halves to 1 half, I'm going to plug in 0. So e to the 0 power would be positive, and then if you plug in 0 for x for the second group, you get minus 5 over 4, so that's negative. So in the end, this section is going to be negative. And lastly, plug in something like a million. Million squared plus 2 times a million minus 5/4 is going to be positive, and e to the million power is going to be positive. So it looks like both of these values here are inflection points because f double prime changes sign. So just make sure you write that as your explanation. So here you can write because f double prime of x changes sign at x equals negative 5 over 2 and x equals 1 half, the graph of f, so our original function, has point of inflection there. All right, so that's part B. All right, part C, is that the table? Okay, it says fill in the missing pieces of the entry in the table below to describe the behaviors of g prime and g double prime, or the second derivative, on the interval -3 to 3, indicate positive or negative. So it tells you exactly what you need to do there, so just make sure you read carefully. Give reasons for your answers. All right, so here, if we were to take a look at the graph, that's kind of important. So let me actually break up the graph. So from -3 to 0 and 0 to 3. So if we take a look, from -3 to 0 is this section over here. We're looking at what the second derivative and the first derivative would be. So if I'm thinking of f prime in this section here, well, our graph is increasing, so we know it's going to be positive. So this is from -3 to 0. Now our second derivative, well, here it's concave up. It's very slight, but it's like a very slow ramp. So this is going to be concave up. So this is going to be positive as well. Now, if we do the interval from 0 to +3, well, f prime, it's still increasing. It does slow down over here, but it's still going up. So it's still positive here for our first derivative. But if we look at our function now, well, it's concave down very slightly. So this one is actually going to be negative. So here, if they were to actually give you this problem, you could fill in the table. So here it'd be like positive, positive. I know you can't really do this in AP Classroom, or maybe not. I'm not sure. And then here it's going to be positive again for your second derivative, and then negative as well. And so notice that it says give reasons for your answers. Unfortunately, the work that I did right here isn't quite formal, so you just have to write it out. And I'll do that right here. So here, I'm going to write g prime of x is positive for -3 to 0 and 0 to 3 because g of x is increasing. Increasing there. And then here, G double prime is positive for -3 to 0 because G of x is concave up there. And then also on the other side, when G double prime is negative, from 0 to +3 because G of x is concave down. Okay, there. Kind of run out of space for D, so give me one moment. Move it down. Okay, but that's it there. So you have your explanations and you'd fill in the chart. And that's pretty much it. Now the last part, letter D. So D, it says let h be the function defined by f of x times g of x. Is h increasing or decreasing at x equals 0? And then give your reason. So let's think about this. So h of x is equal to f of x times g of x. And we want to know if it's increasing at, I'm just going to write it down, increasing question mark at h of 0. So in other words, here, if our function is increasing at h of 0, well, that is also asking if h prime of 0 is positive. So I'm going to actually write positive, or in other words, greater than 0. And so let's see if we can figure that out. So if I want to get h prime, well, I'm going to have to do the product rule here. So h prime of x is going to be f prime of x times g of x plus f of x times g prime of x. And so if I have h prime of 0, then I have f prime of 0, g of 0 plus f of 0, and g prime of 0. Oops. Okay, so you're going to look at your table or you're going to look at your graph and see what values we have. And so luckily I was remembering the part, it says the function g is twice differentiable except at 0. So luckily at least it's um, once differentiable, you can differentiate it once. So we can still get the values. So for f prime of 0, if we think of that, do we have that value? If anything, we could plug it into our equation here. So if we plug in 0 to f prime of x, well, it would be negative 5 over 4 times by 1. So we know it's going to be a negative value here. So I'm just going to plug in negative there. G of 0, you're going to look at your graph. So g of 0 is the value 2. So you could put 2 if you want, but you could also just put a positive value. Wait, do we actually need the value? Let's see. I think I'll actually put the value there. And then here for f of 0. So f of 0, if we plug in 0 for f, sorry, I'm going back and forth. I should just write it up here. But f of 0, oh, they tell us it's -1. So that's where that piece comes in. And then g prime of 0, well, what is the slope of g at 0? So luckily the table tells us it's 2 right there. Okay, so let me see if there's f prime of 0, if there's an actual value. What did we have? Oh, it was just negative 5 over 4. So it's probably a good idea to use the actual value. So negative 5 over 4. Although, because they're both negative, it actually doesn't matter so much. You get a negative here plus another negative, so you know it's negative. But if you want the exact value, negative 5 over 2 minus 2, you would get negative 9 over 2. But in the end, it's negative, right? So it's not increasing. So here you would just say, because h prime of 0 equals negative 9 over 2, which is less than 0, h is decreasing. At x equals 0. All right, and that's it for that one. I'm going to create a second video for the other FRQ.